Hello, this is Mr. Anderson, and we're going to talk about the Matrix. Okay, this is 3.5 and 3.6. You should have a handout to go along with this. You've seen matrices before, so the 3.5 part is actually pretty quick and easy. So let's get on with it. Remember, a matrix is written with these big, large brackets, and this would be considered a 2 by, this thing's going to bug me. This would be considered a 2 by 4. Remember, we read our rows first. Rows. These are rows. You sit in rows. Columns stand up and hold up buildings. So we have 2 rows, 4 columns. Our dimensions are always rows by columns when you do this. So this is a 2 by 4, not a piece of wood. Here's some examples. 2 rows, 2 columns. This is considered a square matrix. Anything that is dimensions, the rows equals the columns is considered a square matrix for obvious reasons. This is a 3 by 2, 3 by 1, 1 by 4. Please keep in mind that this is also a matrix. It's just considered a 1 by 1. Sometimes that comes up. So rows first, columns second. That's important. Adding and subtracting matrices, all you have to do is to add and subtract 2 matrices with the same dimensions. First of all, they must have the same dimensions, otherwise you can't do it. All of these ones that are given as examples here are 2 by 2s. They did a 2 by 2 and a 2 by 2, and you end up with a 2 by 2. Corresponding elements. This is the first row, first column. First row, first column. You add together with the first row, first column, and it produces a matrix that is the first row, first column in the answer. When you subtract, you're kind of just distributing that negative sign into everything there. Example down here, 3 plus 2 is, your answer would be 5. Negative 5 plus 0, negative 5. 1 plus negative 9, negative 8. And 7 plus 10, 17. So addition and subtraction, quite simple. Be careful with the negative sign when we do subtraction. If we were going to add these two, I would take first row, first column, 6 plus negative 3, 4 plus 1, negative 1 plus 0, and 0 plus 3. Most of you will not even need to write this little part down because you know that 6 and negative 3 is 3, and 4 and 1 is 5, and negative 1 and 0, negative 1, and 0 and 3 is 3. Again, a 2 by 2 plus a 2 by 2 equals a 2 by 2. Another example here. This is the same one, isn't it? Did I do the same one twice? 6, 4, negative 1, 0. 6, 4, negative 1, 0. And negative 3, 1, 0, 3. I must have copied the wrong one over. Sorry, skip it. Here's an example of something that you can't do. Can't do. Well, that's still plus. This is a 3 by 2. This is a 2 by 2. Since you have to match up the corresponding elements, there are not enough columns in this one. So you can't add a 3 by 2 and a 2 by 2. Next thing is a scalar multiplication. Scalar multiplication, a scalar, they usually use the word k for a scalar, or the variable k. All you're going to do is you're going to take some number k, and you're going to multiply every single value times the letter k. So k times the matrix A. Every single one of our elements is multiplied by k. So down here, negative 3 times this guy yields negative 12, negative 3, negative 21, and positive 6. Watch your signs. Again, all we're doing is multiplying the same number times every element. So if I wanted to do 2a, 2 times a, I'm going to do 2 times 2 is 4, 2 times 1 is 2, 2 times This is negative 2. This is a 6er, 0, and 10. There's my new matrix 2A. Multiply every single value of the matrix times what we got going on there. Again, if this one's going to be 4A, 4A will be 8, 12, 0, negative 4, negative 20, and 24. All I've done is taken the number 4 and multiplied it times each and every element, and that's called scalar multiplication. Please note that scalar multiplication is much different than matrix multiplication. Matrix multiplication is less than 3, 6. Scalar multiplication is just multiplying all of the elements of a matrix times the same number. Order of operations, what do you do first? 4 times A minus 3 times B. The first thing you always do is multiplication before subtraction. So the first thing I'm going to do is figure out what is 4A. 4A is equal to 8. 4 times 3 is 12. 4 times negative 1 is negative 4. 4 times 0 is 0. And then I'm going to do 3B. 3B. And I get negative 6. And 3 times 1 is 3. 3 times 0 is 0. 3 times negative 1 is negative 3. And then I'm going to subtract them. So really what I'm going to do is take 8 minus negative 6. So you got to watch out. Since I'm doing minus, 8 minus negative 6. And then 12 minus 3. Negative 4 minus 0. That's a toughie. 0 minus negative 3. So if you're a person that chooses to ignore negative signs, this is not a good time to do that, because 8 minus negative 6 is really an addition problem. 12 minus 3 is 9er. Did I hear a 9er in there? Negative 4 minus 0. Negative 4. 0 minus negative 3. Positive 3. So again, order of operations up here. Multiply times 4. Multiply times 3, subtract the results, we end up with a 2 by 2. Okay, this is 3-6. That was the end of 3-5. Again, kind of pared it down a little bit, and there's not too many homework problems you got to work on. Multiplying matrices. This is kind of the big deal. You could multiply two matrices A and B if and only if. Remember, that means very important. Number of columns in A, and columns is always the second value, is equal to the number of rows in B. What I am looking for is this equal to this, and if that this rows, or excuse me, this columns, and this, so we're looking at those inside numbers, and the result of the new matrix AB will be what is M by T. M by T. So if you look at these examples down here, a 3 by 4 times a 4 by 2. These two 4s make it go. That's what has to be the same in order to be able to multiply. And my answer is this 3 by 2, which is what they have over there. Over here, a 5 by 3 times a 5 by 4. The only thing I'm looking at are these columns the same as that rows? And you will see why in a matter of minutes. You cannot do these. This would be not possible. So we're focused on these inside guys here. They got to match up. Your answers are what's left over on the outside. So when I look here, determine whether the matrix product can be defined. If so, what are the dimensions? You have homework problems like this. I look at this and this. And if those are the same, the answer is yes. And I will end up with my answer being a 3 by 3. Down here, I look at this and this. This is a big, fat no. Okay, so first you have to determine if you can do it, and then you can figure out what the dimensions of the answer will be. So what does matrix multiplication look like? Funny you should ask. Multiplying matrices. The element of the mth row in the rth column of matrix AB is the sum of the products of the corresponding elements in row M of matrix A and column R of matrix B. Oh my gosh! Let's put that into some better terms here, shall we? Here we go. Here we go. Let's see if I can make an arrow work. I failed at this before. What we're going to do is we're going to take this row right there, and we're going to multiply it times this column right here. So when you multiply the first row times the first column, you get the element in your answer that is the first row, first column. Watch what happens here. A times E plus B times G. And then we add them together. Now watch how we get the first row, second column. Let's go back to this guy. So I'm going to go with green this time. I'm going to take my first row times my second column. And when I do my first row times my second column, we are going to get this guy in the first row, second column of our answer. So it's kind of a spin thing. If I had a ruler out, I would put it over this and then over this. A times F plus B times H gives me my answer. Now we swing down here. Second row, first column. C times E plus D times G. And then we'll end up adding it up. And lastly, we've got second row, second column. Second row, second column gives us our element that is our second row, second column. C times F, D times H. Let's do an example. You'll see a little bit more of what's going on. Okay, let's start with first row, first column. Here we go. First of all, this is a 2 by 2 times a 2 by 2, which will yield a 2 by 2. So I'm going to take the first row, 3 times negative 2, and you got to show your work on these, plus 2 times 1. That will be the element that is the first row, first column. Next, let's go with big guy. First row, second column. First row, second column. First row, second column. This times this. Let's move to the bottom. Second row, first column. Negative 1 times negative 2. 0 times 1. Second row, first column. Lastly, second row, second column. Negative 1 times 1 plus 0 times negative 1. Then we just do the math. Negative 6 plus 2. 3 minus 2. Well, if I can do the math, 3 minus 2, 1. Negative 3 plus 0. Negative 1 plus 0. There's my 2 by 2. So we get them by multiplying the first row times the first column, and we add. First row, second column, and we add. Let's try another one for those of you that are thoroughly confused. First things first, can I do it? This is a 2 by 3. 2 rows, 3 columns. This is a 3 by 2. 3 rows, 2 columns. Answer will be a. This thing's always in the way. Answer will be a 2 by 2. So I'm going to take the first row and spin it times this first column. So the 3 will match here, this will match here, this will match here. Here we go. We're going to need quite a bit of space. Negative 3 times 1 plus 2 times 4 plus 2 times 0. That was the first row, first column. Now we go first row, second column. Negative 3 times negative 2 plus 2 times 3 plus 2 times negative 1. Second row, because we're in second row and we're in first column. So I'm going to take second row, first column. That gives me my second row, first column. See how that works? Negative 1 times 1 plus negative 2 times 4 plus 0 times 0. I can do that one without a calculator. Lastly, second row, second column. Negative 1 times negative 2 plus negative 2 times 3 plus 0 times negative 1. Now, you can see some things happening here. You can see that, negative 3, 2, 2, negative 3, 2, 2. First row, 1, 4, 0, 1, 4, 0. First column. So that stuff, it does match up. It's very systematic. If you follow the system, you'll be good to go. Sometimes I got to do a little extra math here. Negative 3, 8, and 0. I got 5 there. Here I got 6, and I got negative 2. I got 10. I got negative 1, I got negative 8, and I got 0. I got negative 9. Did I hear a 9er in there? And then I got 2 and a negative 6 and a 0. I got negative 4. So remember, up here we said our answer will be a 2 by 2. So we did a 2 by 3 times a 3 by 2, and we got a 2 by 2. And there we have it. We should probably do one more. Is this the same problem? It's the same problem. How can it be the same problem? Must have copied the wrong one over. My apologies. I think what you should do now is you should pull out your 3.6 homework, and maybe we should multiply one more together. And sometimes it's easier to walk through it rather than listening on the on here. Let's walk through one more from the homework. So I'm going to let you go ahead and do that. And remember, first row times first column yields first row, first column, and so on and so forth. Best of luck. See you soon.